Hello again, and welcome to part four of the IoT ML Lab series. So in part four, we're finally going to get to adding in TensorFlow, and now that we've got our image capture, we've got a video feed, we've got image capture capabilities, and we're going to finally be able to layer on TensorFlow because now that we have that input stream, we can get it to create an output stream. And if you were super excited and ramping up for this being the hardest portion, unfortunately, it's probably going to be slightly disappointing in that this will be one of the easiest portions, actually. And I guess that just goes to show how accessible some of these workflows are, and especially with the advent of a lot of these higher level libraries and pre-trained models, there's a lot that we can do within our reach. So part four will kind of be the end of the first set of the series, the first part of the series, which is going to be about that input, right? So we're imagining that the device is what we've been building up till now. We've got, obviously we've been using a webcam, but if you can kind of imagine that that device is more of a Raspberry Pi or just some kind of smaller kind of developer circuit board with an image capture device attached to it, that's really your IoT sensor. And when we wrap up this portion, we're going to have all the pieces of the puzzle in terms of capturing that information, analyzing information, and then we're going to get into the latter half, which is really going to be about using that information now that it has been collected. What do we do with it? So this is going to be part four. We're just going to dive straight into it. We are going to add in TensorFlow, and we're going to load in some of those image recognition models that we talked about before. So I've got to start at the README as always. So our critical steps are going to be to install Tensorflow.js, and I'll show you how that's done in the glitch environment. We are going to install the Coco SSD model from TensorFlow, which is a very popular image recognition model. And we're going to create a method for taking photos every X seconds, basically. Instead of inputting the live feed, we're just going to feed in a photo every now and then. And that's just to limit the use of browser resources, especially for the purposes of accessibility in this workshop. So we're going to do that. And then we're going to create a component which will analyze the photos and return an analysis based on what it's seeing. So whether it's finding a person or whether it's not finding a person, we should be able to get that information back. And we are going to write functions and properties inside that analysis component to load and process the image, which is going to be a bit of an exercise in and of itself. So again, linking some additional resources, which are highly worth checking out: TensorFlow.js source documentation, and some information about the Coco SSD model that we're going to use. So this is what we've got. Check that out in some more detail, and we will just dive straight into the code. So a lot of similar things. App.view is still the same. We are just mounting that webcam photos component that we wrapped up in the last section. But there's a couple of different components, or sorry, one really new one with a small change to webcam photos.view. So let's dive into that guy. Um, so let's start with the changes. So obviously we can see that there's an image recognition component being used, and we already know the pattern of how to import and declare and then of course use a component. So we'll leave that alone for right now once we know what it's actually going to do. For right now, we just need to know that it's there, and our methods are only very slightly changed. Now you can see that there's probably immediately that there's a missing button here, which I guess we should visualize this before we really start diving into the code. But this is what it should do. So it's going to take a second here, most likely, I hope. Let me try this in a private window in case it's doing something kooky with my privacy settings. Um, I think my laptop is just trying to set itself on fire. Okay. Um, all right, it was just lagging for a little bit, but this is what we're essentially going to get to in this section. So it's still the video capture. With still some feedback messages right here, but at the end, we're going to try and get to this. So this is going to, at every given interval, this is going to analyze the image and tell us how confident it thinks that there's a person in it. So Um, let's see if I can force it to change real quick. I will hide my face. 92, 91. Okay, looks like I can't fool it that much. But the point is that the score is changing, and maybe going out of frame might be much more illustrative than just trying to hide my face. Yeah, it's still a little bit too smart. But the point is, we should be getting real-time data, and if this were staying constant, then that would be a little bit worrying. But um, this is essentially what we're going to try and get into. So without further ado, the button is gone because we don't need a button. I mean, this is meant to work on a video stream, so no button. And instead, we've got that message that I was saying about the interval capture. So going down here, init video is still the exact same thing. So we're not going to worry about that guy too much. Capture is also the exact same thing. So we're not really going to worry about that too much either. So you're probably wondering then what is it that we've done? So in the first piece is in photo interval, we've defined a number here. So this is looks like it's 10,000. I forget exactly if this is in million microseconds, but this is going to define the millisecond microsecond interval at which we're going to capture our image for the analysis. So after we initialize the video, all I'm saying is this is a JS specific syntax, by the way. So wouldn't worry about that too much. Set interval is a built-in function. And then we're going to pass it a anonymous function, which is going to basically just be the same as our capture function. That's this guy right here. So we've already defined it. You could just as easily put some curly brackets and define it here, something like this, and then writing in your functionality in there. But I prefer, especially when it's a bit of a bigger function, just defining it out here. So that's the function callback. And the interval is the other parameter that this set interval API accepts. So look up this guy for some more specifics if you're curious about what and why that's doing. But essentially what it's going to mean for us is it's going to execute this function as an anonymous function at this interval. So 10,000, I've set that as just a starting point. You can make it higher, make it lower. If your browser is less than capable, recommend setting this higher because this is also going to trigger the image recognition that we're going to talk about now. So otherwise, that's it though. I mean, this component is not much more changed beyond this. So really the meat of the Tensorflow.js lives in this image recognition component that we're about to jump into. So before, we're just going to very quickly look at what it is and what it's doing, at least in this component. So we're importing it, we're declaring it, and we are using it. And we're passing a property. It's expecting a property called image, and we are passing it our property, in this case, I guess, part of the local state, but we're passing it our image. And this vbind you probably haven't seen before, but it's just shorthand, or rather, this is shorthand, whoops, this is shorthand for this. So you can really use either or, totally up to you. The reason I put this in here is just to throw you for a curveball, but also to let you know that if you see this, it's exactly the same as this for the most part. So we're passing it a dynamic reference to an image object, which we've got right here. I guess this is very slightly different than the last component in terms of, I believe the last part we had a source here, which was just a string literal. Um, this actually is doing the same thing, but it's slightly different. So instead of having that source, is whatever the heck string, because we don't need to render that image anymore, that was just kind of a show and tell. We have just created an empty image container, and then we are setting the source of that image explicitly with the exact same canvas to data URL function. So that much should look familiar. All right, so this is our component. We know that it's passing or it's accepting an image. And now we got to see how that does what it does. All right, so here it is. I'm going to very quickly scroll to the bottom and show you that it's 83 lines. So if you had any dreams of complexity and crazy stuff and formulas here, I'm sorry to disappoint. But the good news is that this is really easy to use. Like I said, it's accessible. It's easy to get up and running, and you can always add more layers of complexity and information, but at least this is a starting point. So the template here is very, very rudimentary. So all this is doing, and I'll show you actually explicitly which component. This is going to take a hot second to load up, so let's just give it some time. This is just the results table is all that this is in terms of the template at least. So there's a message here, very similar pattern to what we've done before, just something to render what the heck is going on inside this component in terms of, something that the user can read. And then this is just a table. This is a raw native HTML element, just a data table. And all I want to see is the class and the score. So this model is going to predict the class. So basically meaning whether it's a person, a cat, a keyboard, stuff like that. The Cocoa SSD model actually has, I think, about 256 images that are object types, sorry, that it's trained on. So it's actually very multifunctional. Um, and then we're just going to display those, the class and the score. That's all we're going to do. We're going to create some headers, some rows, and that is it. So before we get into those specifics, let's see what's happening in here. So the prop we already talked about, right? This is expecting an image. And if an image is not passed in, this is not going to be able to do the analysis. It's just how Tensorflow.js works. The other things it's expecting are these packages, which are Tensorflow.js and the Cocoa SSD model. So how do we get these in here? This is glitch. This isn't, Node. We don't have npm install. Well, package.json, if you click to that file, that's really going to be your best bet for adding packages. So you can see here it's flagging me for updates, but I don't really care about those. What I want to do is just show you how you would add a package. So you would click add package, and it's just as simple as start searching for a package. And once you see the one that you're looking for, just click it in. And I don't think it's going to autocomplete for the ones that I already have, which is why I didn't do them. But these are the two that we want. We want TensorFlow, TFJS, and we want from TensorFlow models, we want this Cocoa SSD guy. And this is, yeah, just type them in here. It'll autocomplete. And they will get installed. And obviously, if you're starting from this template, you already have them in there, so you don't have to worry about it. If this was a traditional console, or sorry, if this was a traditional Node.js environment, or you were using the Vue CLI, I was hoping that this terminal would pop up, but okay. Well, I was gonna try and demonstrate, but I guess I'll do it in a kookier way. So if this was, your own project on a command line, created by command line from the Vue CLI or something else, all you would really do is, you would cd to the directories, my project. This isn't a real directory on my machine, so don't worry about that. But then you would do npm I at TensorFlow/tfjs. So if you were doing this locally, this is what you do. If you're doing it with the rest of us in Glitch, you just go add package, type it in there. So fairly easy enough. All right, so let's go back to this guy. Once you install those and Glitch is done building and all that stuff, just drop in these import statements like this, and we're good to go. So let's dive into what this does. So the mounted hook is something that we already know about. We want to execute a couple of things when this happens. So the first thing is that we want to load our model. So what does the loading of the model look like? It looks a little bit like this. And this is coming exactly from the documentation of this model, of the Cocoa SSD model. So take a look at this. This isn't code that I invented or anything like that. This is from their API. So this is essentially what you do. You call the load function. And then this is well, almost, I guess. I would have loved one more step, but this is a traditional kind of JavaScript function chaining syntax, where as long as the inputs are the same, you can essentially do multiple calls, chain calls on the same object, if you had different functions, for example. So we're going to load it first, and then we basically have a callback, and we're going to call it model. If there is a model, obviously, if the loading is successful, we are going to set that to our local state. Model is going to be model. And I've created a custom logging function here. Nothing too special going on here, but it's just going to console log the message, and it's going to write that message to our local state so that this guy, so that we can visualize it even if we don't have the console up. So that's all that handle log is going to do. And handle error is going to be very, very similar. We're just going to error log it to the console, and then we're going to write it to the message just so that we can see it in case our console is closed. And actually, I guess I went really boots and suspenders here. We're also going to throw up a Chrome alert So those can just hang out right there. But essentially, if it's successful, we're going to log that it's successful, and if it's not successful, we're going to handle that error. And you remember the syntax from the last section where I had forgotten about it, but put it in. So this is a good practice. You want to have a pretty robust handle error function, probably a lot more than this too, but for the purposes of this, I think we're in good shape. All right, so that's essentially what happens when this all is loaded, and this is the message that we want to display when it's loaded. Let's see if I don't emulate my laptop when I try and refresh it. So right now there is no message because it's still loading, right? And as soon as that callback fires back successful, that's when we're going to get the message. There we go. Before that, it just wasn't rendered. So back to this. This is our load model function. That's kind of wraps it up. And then the other one is this looks exactly like our capture function from before, right? It's really the same exact API. We're using the setInterval function, and we're passing it a function that we've predefined. In this case, though, it's not capture, it's predict, and we're passing it an interval. Now, I've been a little bit lazy with this, I'll admit. So as opposed to waiting for a fresh image from the parent component, I've just cheekily set this interval to be, I guess, 1,000 milli microseconds longer than the parent component. So the image basically gets written at this number, and then 100 whatever seconds later, or sorry, 1,000, this gets predicted. So that's a little bit lazy. I'm going to be honest with you. And theoretically, you should probably be watching for changes to the URL of the PNG that the parent component is passing in. But you know what? That's something you guys can implement on your own. That's your homework. This is going to work for our purposes. It's essentially going to make sure that we have a new image to predict every single time. So that's all we're going to do. We already know how this guy works. The only thing we don't know is how the predict function works. But it's actually really, really simple. And again, this is coming from the documentation of the Coco SSD model in that GitHub repository that I linked up here. This isn't anything that I figured out or created myself, really. So we're calling a reference to our model, which lives in our local state. We are calling the detect function, and in this case, our image is coming from the parent. It's actually a prop. It's this guy right here. And after that, we're basically saying that there's going to be a promise, and once the promise is resolved, we're going to get this callback object. I'm going to name it predictions because I like them to be somewhat logical. And here we're going to see something interesting that we haven't seen before. So this $sign data, what the heck does that do? This actually looks familiar somewhat because we've seen this $sign refs, but this is essentially a helper way to explicitly make sure that you're going after this guy right here that lives in the data of our local state. Because sometimes when you are in the middle of anonymous function, and not just that, but in the middle of a function chain like this, when you do this dot whatever, whatever, this actually is not referring to the view instance. This is referring to some other just thing that's specific to the anonymous function or to this function chain. And that prevents us from being able to work with this. So there's a couple of workarounds. Some people do something like this. They do like let um, data equals this, for example. And then here they do data.image analysis equals, whatever, whatever. That's one way of doing it. I sometimes do it, sometimes don't. I feel like it's kind of a waste of local memory a little bit, especially given the context. But in cases like this, I like to do this, and I think the developers, the core team of Vue.js, say that we should do this fairly rarely. So, take that with a grain of salt, do it at your own discretion. But this is going to make sure that when we say image analysis, that we mean image analysis. We don't mean some other object or some other thing. And all we want to do is get those predictions in there, get them out of this anonymous function into, no man's land and into the local state where we can actually do something with them. And then, of course, we're going to just console.log agent predictions and the predictions just in case we want to see what's going on at a low level. And we should probably just use the handle log function as well. But if you're wondering, and actually you might have already figured out why I didn't use it, is because explicitly getting a reference to this handle log function inside this function chained anonymous function is not going to be a fun time. And I kind of didn't feel like dealing with it. So instead of doing, something like this, I just skip that altogether, and we're just gonna do something simple. We're just gonna console log it, and it'll be fine. So that's the async predict method. Um, this will get fired off every now and then, a little bit later after we get the image, and then we're gonna create some results, right? So what do we do with those results? And what the heck is this computed flag right here? So computed is a really, really interesting part of Vue. This is basically um, a series of, what do I want to call them? Objects that are being evaluated live constantly. So this is a great way for, I mean, it's a great way for doing a great, a number of things. But for our purposes, it's great for making sure that these are the latest that they can be. So when I'm looking for agents and scores and I want to display them to the user, I want to make sure that I have the latest information. And if that information changes, I want to make sure that my data bindings in the DOM are dynamic, they're two-way, and they're instant, that I get feedback right off the bat. Um, so this is a simple, very simple implementation of this because the analysis that comes out, we're saving an array. And the object that the model is spitting out may or may not be the way that we want to consume it. So let's actually very quickly look at the dev tools and see what's coming out in terms of image analysis. So webcam photos, image recognition. Okay, so this is computed, but where? Okay, image analysis comes out as an array of a singular object because I'm only one person. If I had something else with me, I'm trying to see if there's anything else around me that I can recognize. I don't think there is. Um, but it's coming out with this, a class, a score, and a bounding box array in case we wanted to draw one of those neat little, cyan bounding boxes to verify that it's working logically and it's not thinking like these headphones are a person or something else, and it's actually thinking, I'm the person. Um, but the point here is that this data is coming not in the exact way that we want to consume it, right? Like we want to create this table right here, super basic, just a header and some information. And the table wants specific rows and columns defined. Okay, so how do we do that with this array that just comes out and it happens to be whatever the developers at Google decided it's going to be? We use computed, or at least I do. So computed is going to be evaluated constantly. My computer is going to self-immolate, so I'm going to turn that off and save some resources before my fan takes us set to outer space. Um, so we're essentially going to do a very simple operation. We are just looping over the image analysis array, and we're just extracting the class. That's it. The scores, same thing. We are looping over the image analysis array, and we're extracting the score. That's it. And here, when we define our rows, we're getting into something interesting as well, which we haven't encountered before. This is a Vue loop. V4 is a dynamic loop which will iterate over a collection and will create as many elements as there are in the collection. So if in our webcam, well, actually not if, but when, I mean, I'm currently just alone in my office, but if this was an IoT device and I put it in my company's, lunchroom or something, in our meeting room, whatever, there's going to be a lot more than one person, and there might be less than one, but there might be no people. So this table, this DOM element has to react, right? Because we can't just say we can't just write 100 rows, and if they're not all filled, then oh whatever, it just looks weird, right? We want as many rows as there are people, and V4 is going to allow us to do that. So all we're saying here is that we're going to loop over this is a specific syntax. It means that we're going to loop over the collection of agents, and we're going to work with the item and the index. You could also just do item in agents. This will also do it. I like this because for a lot of the Vue loops, you want to specify a key just in case you want to go back to it, or just for debugging purposes in the DOM. Honestly, it's not critical, but it's a good practice. Um, so I basically just end up using the key as a helper to the score, but it doesn't matter. So we're looping over this collection of agents, and there's an item and an index. So the first item that we want to display is the actual item, and the second item that we want to display is we're going to try and pull from the array of scores. So let's visualize that because this probably sounds kind of kooky as I'm displaying it. Um, so it's going to take a second to fire up. Oh no. Oh no. Let's run out of resources. Let's refresh this guide. I hope it works though. Sometimes glitch runs out of resources, and then my front end, of course, as you can see, my fan is. I think we might be good. Awesome. Um, so in the view DevTools, let's see what those results are actually giving us, those computed properties. So the image analysis is what we saw before. It's still that thing, but the computed properties are giving us basically an array. They're just separating the pieces of the object. That's just the way that I happen to want it. I want a list of people, or sorry, a list of classes and a list of scores. So that's what we got. And if this was 2 people or 3 people, whatever, this array would grow to be that number or shrink to be that number as it is. And these rows would then obviously increase if there's more people. And that's all because of the v-for loop. But essentially, because I'm looping over the agents, I have to do this kind of weird thing where I access the scores through basically the index of the loop. And I just happen to know, because of the way that I've done these computed properties, that they're going to be ordered the same. I haven't sorted them, so I don't want to get too much into that. But the point is, we're going to loop over the results and just display the class and the scores. That's it. Okay. And in a nutshell, that's really it. Because once we have our results, we can create this table. And the only other aspect of this that I don't think we've covered is the v-if. But we encountered v-if in the last module, so you probably know exactly what this is. This is just saying that we don't want to see this results table unless the image analysis array is of a length greater than 0. Or I guess of a length that's not 0, because you're never going to have an array with a smaller length than 0, unless somebody decides to drop some weird JavaScript knowledge on me, which with as kooky as it is, I'm sure somebody can and will. But that's just it. We're going to get this table. We're going to get the results only if there's any results to see. That's all that is. We're going to show the results, and that will be that. So the critical pieces of this are all in place. And the one piece that we really don't have yet is to actually save the data somewhere. And I kind of hinted at that a little bit at the introduction, the slideshow introduction. But that's a fairly straightforward thing to implement. And whether you're saving to a database or to a CSV, the fact is that we have gotten our analytics to an array or a collection of arrays, whatever you prefer. We've gotten the raw analytics out of the model. We've worked with them in order to transform them into something that we can consume. Now, this might not be the way that you want to transform them. You might want to do something totally different, and that's fine. But the point is that you have the tools, you know how to use computed, you know how to use local state, and save things and manipulate them in a meaningful way. And I think that's really the main of it, the main part of it, the biggest part of it. Once you have that, there's a number of different tools you can use to save that information or to push it somewhere else. But as far as our device goes, this really is core. And with that in mind, again, within the context of the workshop, since most of us don't really have easy access to a conference room or to a dynamic space, in the next part of this workshop, we're going to use with some data provided by Spacebot that they've collected through one of their projects. And we're going to leverage that data to try and build a predictive model to hopefully try and get us closer to understanding when a place is going to be occupied and when it's not. So obviously, if we can imagine one of these sensors in a room, it's looking at people. Depending on how many it detects or doesn't detect, that's going to give us a hint to whether or not the room is occupied. The resolution will not be perfect, and it'll really depend on the scope and size of your space as well as your actual image detection unit. But as a concept, that's really it. So that's it for the first major half of the workshop. Join us for the next half, where we're going to be really diving into working with some raw data, some CSV data that perhaps you might have saved from your device. And we're going to use Brain.js to put together a very simple, high-level neural net to try and play with those different parameters that we've collected. Time of day, number of people, score, all of that good stuff. Try and combine them into some kind of meaningful predictive analytic model and see if this is even the type of data that can be predicted, because it might not be. This might be such an organic thing that it's not really predictable. So join us for the next half and we'll figure that out together.